Hello and welcome. Today we're going to be looking at some permutation and combination questions. This first one, really all we're looking at here is to figure out if it's a permutation or a combination. So we've got a team of 16 soccer players. They got to pick a captain and co-captain. In this case we're going to say permutation because order does matter. Whether you are captain or co-captain does make a difference. So this one would be a permutation. And the second one, selecting which 7 players will be in the batting order on an 11-person team. So the key word there, selecting, and again it is a batting order, but just selecting which 7 players will be in the batting order, not actually putting them into an order. So in this case we're going to go with a combination because again it's just selecting the people that will be in that order, not actually defining what the order would be. With these next two questions, same idea, deciding whether it is a permutation or a combination. So here we've got the student body of 120 students who wants to elect a president and a vice president. Well, so again, order would matter whether you're president or vice president. This one would be a permutation. And the second one, the batting order for 9 players on a 12-person team. So actually figuring out the batting order would be a permutation as well. So again, like on the previous slide, the question was a little different, just deciding who was going to be in the batting order, but not deciding the batting order itself. So in this case, a permutation here. Here we're actually looking at finding the number of possibilities in each scenario. In this case, student body wants to elect a president, vice president, secretary, and treasurer. So in this case, we would be talking of a 15P4. There's 4 positions: president, vice president, secretary, treasurer. We are electing them from a group of 15. And again, it is a permutation because it makes a difference whether you get elected to which of the 4 positions. So it would be a permutation. 32,760 is what we come up with for that one. Here we're looking at a 3-digit lock. Now we want to use the digits 1, 0, and 9. We don't care what order, so really all the different orders of 1, 0, and 9. So this would be a permutation from a set of 3 items. How many different arrangements can we have of all 3 of those? Which would be the same as a 3 factorial. It's 3 times 2 times 1, so we just get 6 different combinations on that 3-digit lock. And again, notice the use of the word combination in terms of the lock, but again, really a permutation question. Here we have the same basic idea. Student body wants to elect 75, or of 75 students wants to elect a president and vice president. So again, this would be a permutation from 75 students electing just 2. And so that turns out to be 5,550 different ways that can happen. Alright, this time we have James and Alberto planning trips to 8 countries this year. There are 11 countries they would like to visit. They are deciding which countries to skip. So in this case, there's 11 countries they would like to visit, but they can only visit 8. So that means when we're deciding to skip, we're deciding which 3 to skip. Now this would be a combination, and so we would do a combination from the set of 11. How could we figure out which 3 to skip? And again, that would be the same as an 11C8. So either way you calculate that, it's actually going to end up being the same number. I would think of it as an 11C3. How can we skip 3? But it's going to have the same value as an 11C8. And we end up with 165 as the result. Here we're looking at stating whether it's a permutation or combination and finding the number of possibilities. We have 4 out of 14 students will ride in a car instead of a van. So talk about having them ride in the car, not necessarily deciding who's driving and who's sitting where, but just who's riding there. So this would be a combination of the 14 people selecting the 4 that would ride in the car instead of the van. and we end up with 1001 results. Alright, in this scenario we have Leah has homework in 4 subjects. She's deciding what order to complete them in. So again, the use of the word order would signify permutation. And so we have a permutation. We're looking at the set of homework being 4 subjects. She's deciding to do all of them, just what order. So that's really the same as a 4 factorial, which would be 4 times 3 times 2 times 1. So we're talking 24 as the result. Here we have 45 applicants for 2 software tester positions. Since the positions are the same, we would be talking about a combination. So from the set of 45 people, we're going to select 2 to have the job. And again, combination because the positions are the same. And we end up with a total of 990 ways that can happen. Last one here, we've got a group of 45 who are going to run a race. Top 3 get gold, silver, and bronze. So this would be a permutation because we care for gold, silver, or bronze. 45P3. And we end up with 85,140 different permutations there.